Hello friends, my name is AJ and welcome back to the last AP Computer Science in-depth review, and this is going to be for the last unit, Unit 10, which is recursion. Recursion is a little bit more of a complicated unit for a lot of people because of the entire concept. It's very, it's more of applied and you don't really write recursion type methods, but you do a lot of multiple choice questions with them. So what I'm going to be doing in this video is I'm going to be going over what recursion is, and I'm also going to be showing you many examples so that you'll be able to be very confident. I'm going to show you a way on how to solve recursion questions almost always correctly, all right? So without further ado, let's get started. All right, so looking over here, we have the word recursion. And if you're not familiar with recursion, you probably don't know what it even means. So recursion refers to the idea of a method. So the idea of a method running itself, right? Or calling itself kind of inside of itself. So running itself inside of itself. Now you may be wondering, what am I actually saying here? What does this mean? Running a method inside of itself, right? Or running the same method, running itself inside of itself. Well, let's look at this example over here. And forget the question. We're just going to look at the function. So this is an example of a recursive function, or a function that utilizes recursion. So the first thing that you may notice, you may be wondering, well, how is this different than any other type of function, right? Why is this one recursive and the other ones are not? Well, I want to point to one specific thing. You see here that in the header of the method, you can see the name of it. And the name of the method is mystery. But if you notice here in the last line of the body of the method, you actually see that you are calling mystery, or the method mystery, inside of itself. You're calling the same method that we defined inside of itself. And that is the entire concept of recursion, where you're basically calling, you're repeating a process inside of itself. Now you may be wondering, well, how does that actually even work, right? How do you get that to stop? Because once you start, like let's say you call a method inside of itself, wouldn't it just repeat forever? Well, there is actually a way to stop that, and it is with over here with an if statement. If you have an if statement for example, a certain parameter, and your parameter changes when you actually run the recursive line over here, then if you ever reach the condition of the if statement, you can actually return something that does not return itself, does not return the method. And that will cause everything else to fall into place, and it will prevent it from running forever. So I'm going to be showing you an example of how we can actually solve, because the majority of these questions that you're going to get on recursion is going to ask you to say, for example, what is the value returned as a result of a certain call? And that's where we're going to be going over today. So these questions that are on this document, these are from a very good resource called Runestone Academy. And I pulled 3 questions from there because I thought they were very good questions to kind of go over as an example. The link to it will be in the comment section, in the pinned comment below. And I definitely recommend doing extra practice, especially once we go over how to actually solve these type of questions. It's going to be very, very helpful to you. And another thing that I want to mention is for the last units, units 1 through 9, I've actually had a practice test with Unit 10. I'm not going to be including a practice test for this particular unit because I feel that the questions that I will ask, first of all, there's no FRQ that I can reasonably ask for recursion and expect anybody to even be able to solve, or also the fact that there's not on the FRQ, on the actual FRQ for AP Computer Science, you're not going to be ever writing a recursive function. So the idea of kind of giving you an FRQ for recursion is not going to be very helpful, simply because you will not actually be able to, or you won't need to ever write a recursive function or a recursive method as a actual, as something that's graded for the FRQ section. You're only going to see recursive questions in the multiple choice section because that is where, that is usually where they're going to ask it. And they're going to ask it just like this, where it's asking you for a returned value rather than, asking for asking for you to write something. So first, the FRQ then wouldn't have worked, and then the multiple choice, there are so many good resources that are just generally better, in my opinion, than trying to do that in general. So, and that's why this particular this resource for Runestone is what I'm going to be linking to. There's also Coding Bat, which is very, very good for any of this type of practice. Again, just the entire, the questions I would have made anyway would have been so similar that I didn't see any benefit, rather, of adding a new practice test to it. Now, the other one with inheritance, and that would have been useful, and that is useful because you have a lot of definitions and trying to figure stuff out, but for recursion, it's all kind of practice-based. All right, so let's get started with this question. I'm going to be showing you how to answer these type of questions inside of Java, these type of recursion questions. All right, so we're going to get started here. It says, given the following method declaration, what value is returned as the result of the call mystery5? So basically what this is saying is that the parameter for the function, or for the method I'm running, is 5. So over here, what I can do is I'm just going to write out mystery, and then I'm going to say 5. And I'm going to do an equal sign. And this is how I solve all of the recursive problems. I definitely recommend you use this method. So what you're going to do is you're going to look at number 5 over here. And you're going to use 5 as your parameter for your actual method. Now you're going to figure out what this is actually going to return, right? Or what it's equal to in this case. This is going to be what it returns. And what it's going to return is, well, we're going to look at this if statement. If my input, my parameter is equal to 0, it's going to return 1. Well, 5 is not equal to 0, so it's definitely not going to do that. It's going to go to the else statement. And in the else statement, what I'm doing is I'm going to be returning 3 times mystery again, and then n minus 1, or 5 minus 1. So over here, what I'm going to be setting this equal to is going to be 3 times mystery, right, 4. And the reason I put 4 is because it is n minus 1. Okay? So now I've written out one of my actual calls when I do 5. But of course, I can't say what is the value returned because I don't know what the value of mystery 4 is, right? If I give you a math problem like this, and let's say that 5 was y, and I say equals 3 times x, right over here, you can't give me 3x as the value. You have to figure out what x is actually equal to. And that's kind of what we're doing in this case, where we have to figure out what mystery 4 is actually equal to. So I'm going to put mystery 4 equals, and now we're going to figure out what it is equal to. So again, looking over here, we can put 4 as our parameter. And you check, is 4 equal to 0? Well, it is not, so we're going to go to the else statement. And in the else statement, I'm going to do 3 times mystery, but this time instead of 5 minus 1, it is 4 minus 1. So really what I'm doing is I'm going to be setting this equal to 3 times mystery 3 right over here. Because remember, my input parameter was 4, so 4 minus 1 is 3. So now, after this, right, I need to, and actually I'm going to move this over a little bit so I give myself a little bit more room. I now need to figure out what mystery 3 is actually equal to. Because in order to find out what mystery 4 is equal to, so that I can fulfill this up here, I need to figure out what mystery 3 is equal to. So I'm going to try to run mystery 3 and see what it's equal to. So I'm going to put mystery 3 equals. Now I'm going to go back over here to my actual function, and I can put my parameter as 3. Well, is 3 equal to 0? No, it's not. So I'm going to return 3 times mystery 3 minus 1, which is going to be 2. So I can do here 3 times mystery 2. And now we can continue the song. We could say mystery 2 is equal to, and of course we know that 2, if I put in 2 over here, I'll check my if statement, 2 is not equal to 0, so I will run my else. And my else in this case is going to be 3 times 2 minus, or 3 times mystery 2 minus 1. And 2 minus 1 is just 1. So over here I can set this equal to 3 times mystery 1. Just like that, okay? And now what I'm going to do is I'm going to try and run 1. So I'm going to put 1 in my parameter. Is 1 equal to 0? No, it's not. So I need to now run my return. And my return is going to be 3 times mystery with the parameter of 0, because n, or 1 minus 1, is equal to 0. So over here, I can simply write mystery 1 is equal to 3 times mystery 0. So now all we have to do is figure out what mystery 0 is. Well, now we finally reached this if statement, right? Because I'm going to say over here that integer n is equal to 0. So if 0 is equal to 0, which it is, then we're going to return 1. So this time when we run mystery 0, this is going to be equal to 1. And now if you notice here, we can finally stop in the sense that we don't have to call any more mysteries or kind of try it out. All we are now left with is a static value. So now you may be wondering, well, what's next? You haven't figured out what mystery 5 is equal to, and that's what the question's supposed to be. And that is what we're exactly going to do next. And we can now kind of substitute in values. Let me give an example over here. Let's say I have y is equal to 3x plus 2. This is a math problem. You're trying to figure out what is the value, the numerical value for y, okay? Well, this becomes very difficult, but what if I say that x equals 2? Just like that. Well, if you know that x equals 2, all of a sudden it becomes really easy, because all you have to do is you have to take the value here. I'm saying that x is equal to 2, right? X is equal to 2. So I can simply replace the x over here with the value of 2. And then that becomes 3 times 2, 6, and then plus 2, which gets 8, right over here. So that idea of substitution in math and with variables is what we're going to be doing up here. So first, right, I'm going to say that mystery 0 I know now is equal to 1. So when I go one level above it, I say mystery 1 is equal to 3 times mystery 0, right? Well, now we know what mystery 0 actually is. We know that mystery 0 is actually equal to 1. So if we can solve the math over here. 3 times 1, just like that, is equal to 3, right? 3 times 1 is equal to 3. And I don't know what happened there. This is a 3. Okay, so now we know what mystery 1 is equal to. We know that mystery 1 is now equivalent to 3. So now we can look one level above it. And you can see here, it says mystery 2 is equal to 3 times mystery 1. Well, now we know the value of mystery 1. Mystery 1 is actually 3. So, right, because I said here, mystery 1 is equal to 3. So I can simply cross out mystery 1 and put in my value 3 here in its place, because I solved for what it actually is. So now I can say 3 times 3. 3 times 3 is equal to 9. So I can put 9 right over here. All right, now, right, I have mystery 3 above. Again, I'm going one level above. And it's saying here that mystery 3 is equal to 3 times mystery 2. Well, what is mystery 2? Mystery 2 over here, we said, is equal to 9. So I can cross out mystery 2 and put 9. And that means that 3 times 9 is equal to 27. Therefore, mystery 3 is now equal to 27. Now we can go one level up again over here, one level up, and I will choose this over here. So it says that mystery 4 is equal to 3 times mystery 3, right? Or mystery 4 is equal to 3 times mystery 3. So what is mystery 3 equal to? Well, we know that mystery 3 in the last set, we said mystery 3 is equal to 27. So I can cross out mystery 3 right over here and put 27. And now you can solve for 3 times 27. 3 times 27 is 81. So I'll put 81 over here. And now the last one that we are going to be doing right over here is mystery 5. And it says that mystery 5 is equal to 3 times mystery 4. Well, we again solved down here that mystery 4 is equal to 81. So I can simply cross out mystery 4 and put 81. And so now you can do 81 times 3. Okay, and if you do the math, right, this here is 3 and this is 24. So this would be 243. So if you look, what we've done is it said over here, given the following method declaration, what is the value returned as the result of call mystery 5? And now we have said over here that mystery 5 is going to be equal to 243. So in our answer choices, 243, 03, 81, 27, the correct answer would be, right over here, 243. Okay? So now we're going to be going over here, okay? And it says, given the following method declaration, right? What is the value returned of the call product 5? So this time we're working with another 5 as our input. So we can look at our function and let's just write it out. So I can say over here, product 5, right? And what is product 5 equal to? Because product 5 is, again, what I'm trying to solve for. So I can say that product 5 is equal to, if I put 5 in my input over here, is 5 less than or equal to 1? It's not. So I'm going to return n times, but this time it's product n minus 2. So over here, n minus 2, that's going to be n. So now you notice here I have n also. I have n, right, which is 5 as my input. So 5 times product n minus 2. 5 minus 2 is 3. So this is going to be equal to 5 times product 3, right over here. And so now we notice that we've called product 3, so we need to solve for product 3 over here. So product 3 is going to be equal to, and now we can again change it up. So I can put 3 as my parameter. Is 3 less than or equal to 1? It's not. So we're going to return n, right? And remember, n is 3, so 3, because that's my parameter. So 3 times the product of n minus 2, which is 3 minus 2. So 3 minus 2 is 1. So I will write over here, this will be 3 times product of 1 over here. And again, I'm going to move this over. And so now the last one is going to be product 1, because I call it over here. So product 1, I'll write it in, equals, and now you can see over here that if I put in my input of 1, is 1 less than or equal to negative 1? It is, so we're going to return 1 as our final result. And if you notice over here, we do not actually call, let me write 1, you do not actually call any more methods. Therefore, we don't have to do anything more. We are done. Now we just have to, substitute in our values. That's step number 2. So I'm actually just going to write this up here in kind of a step form. So step number 1 is going to be find or write out all of your calls right over here. So write out all calls to the recursive method. And then step number 2 right over here is going to be substitute values. Those are your 2 steps in order to solve the problem. So over here, the last thing again I'm going to do is substitute the value. So I know over here that product 1 is equal to 1. So when I go 1 above, it says that this is equal to 3 times product 1. Well, I know that product 1 is equal to 1. So this is going to be 3 times 1, which is 3 over here. Okay? And then over here, the last level up, it says that this is going to be equal to, let's redo that, that this is going to be equal to 5 times product 3. Well, what is product 3? We know what product 3 is because we just solved for it. Product 3 is equal to 3. So I can simply go up here and I can say that this is going to be 5 times 3. And 5 times 3 is 15. So when it asks us to solve for what is the result of the call product 5, you know that product 5 over here is equal to 15. So E is the correct answer. Okay? And now we go to the last one, and this is a complicated one, all right, over here. Or a little bit complicated. It depends on your view. But if you look over here in your return statement, you have two calls. Okay? You actually have two calls. So we need to figure out how to actually solve this here. And we're going to use the same method that we did, because the method that we used in the last two problems works in this one as well. So it says, given the following method declaration, what is the value of f5? So again, they're using 5 as our input variable. So I'll put f, right, 5, f5, and this is going to be equal to what? Well, let's see. So 5 is my parameter. So is 5 equal to 0? No, it's not. So now we go to the else if. Is 5 equal to 1? No, it's not. So we go to the else. And what we're left with is we return f times 5 minus 1, which is 4, plus f 5 minus 2, which is 3. So f5 is equal to f4 plus f3. f3. Just like that. Okay? So now what we need to do is we call two functions here. But really we're going to start with the first one. So we're going to say f4 is the next one down, and we have to figure out what f4 is actually equal to. So we can repeat the process, and we can put in 4 as our parameter. And is 4 equal to 0? No. So then we go to the next if statement. Is 4 equal to 1? No. So we go to the else statement, and you can see here we're going to return f 4 minus 1, which is 3, plus f and minus 2, which is, or 4 minus 2, which is 2 over here. So we're going to be returning f3 plus f2. Okay? And now we need to figure out what f3 is actually equal to, because not only is called here, which is the first one in this, and it's also called up here. So you have to figure out what that is going to be equal to. So we can write f3 equals, and we can again do the same process that we have done with the others, and we can figure out what all of these values are. So we can put 3 as our parameter. Is 3 equal to 0? No, so the first if statement fails. Is 3 equal to 1? No, it's not. So that if statement fails, and we're left with return fn minus 1. So 3 minus 1 is 2. So f2 plus fn minus 2. So 3 minus 2 is 1. So this will be f1. So I can write over here, this is equal to f2 plus f1. Just like that. Okay? Now we are going to work and try to figure out what f2 actually is. So I'm going to write f2 over here. So let's call our parameter, or let's put our parameter as 2. And so now we look. Is 2 equal to 0? No, it's not, so we skip over that. Is 2 equal to 1? No, it's not, so we're going to skip over that. We're going to return f, 2 minus 1, which is 1, plus 2 minus 2, which is 0. So now this is going to be f1. This is going to be equal to f1 plus f0. And this is probably getting repetitive now. And the reason that, again, I want to do it this way is because this prevents a lot of problems. You may have already finished this by the time, while I'm talking. But that's actually a very good thing. Once you're starting to get the hang of it and you're able to kind of repeat this process, you can go a little bit quicker, right? I don't need to physically sit here and kind of check every single if statement all the time. If I know they're all going to fail, I can simply write it out like this. Of course, you don't want to be careless. You want to actually, make sure that you are paying attention to your if statements inside of your code, just so that you know how things are going. So now we can call f1 right over here, because that is the next. So now we look, right? So we put 1 as our parameter. Is 1 equal to 0? No, it's not, so we skip over it. Is 1 equal to 1? Yes, 1 is equal to 1. So because 1 is equal to 1, we will return 1 as the result of this. So this is going to be equal to 1. Now this is great, and some people will stop here, but remember, we have one extra call. Right, we've done all of this, but we called in this one F1 and also F0. And F0 is the only one that we have not called yet in all of our calls over here. So let's do that. F0 is equal to, and again, we put our parameter as 0. And you can see that because 0 is equal to 0, this function will return 0. Just like that. All right, so now we have done with step 1, which is writing out all of our function calls. Now we can do substitution. So right over here, I know that this value and this value are actually already solved for. So I'm going to put a little check marks. These values are actually already solved for, which means that I can move up all the way to this one that is unsolved. And it says that f2 is equal to f1 plus f0. Well, we know that f1 is equal to 1 because that is what it says so right over here. And we know that f0 is equal to 0 because we solved for that down here. So we can say that f2 is equal to 1 plus 0. And 1 plus 0 is 1, right? Not 10, it's 1. 1 right over here, okay? So now we can look and go one further. We have now solved for f2, right? Now we want to solve for f3. So I can say, well, f3 is equal to f2, right? And what we said that we solve for f2. f2 is equal to 1. So I can say over here, I can cross this out and put 1 plus, and then we have f1. And we know that f1 down here, we solve for it is equal to 1. So 1 plus 1 is equal to 2, right over here, okay? So now we have solved for f3. Now we could solve for f4. So f4 is equal to f3 plus f2. Well, we solved for f3 in the last step, right? f3 is equal to 2. So I can cross out f3 and put 2 here. And we know that f2 right over here is equal to 1. So I can cross off f2 and put 1. And 2 plus 1 is equal to 3 right over here. All right, so now we're going to go to the last step, and that is f5. And we know that f5 is equal to f4 plus f3. And we know that f4, because we solved for it, I'll add my little check mark, right? f4 is equal to 3 right over here. So what I'm going to do is I'm going to cross this out, and I'm going to put 3 over here. So I just check mark that again. And then over here, we say that f3, we know that f3, because we solved for it, is equal to 2. So I can cross that out and put 2. And this is now f3 is equal to 3 plus 2. And 3 plus 2 is equal to 5. Right over here. So f5 is equal to 5. So because it's asking for us what is the result of f5, so we can just look at our answer choices, 8, 3, 5, and 0. And our correct answer choice is D, 5, as that is our return. All right, so the concept of recursion is generally a little bit more difficult, especially these type of questions. You know, you look at them, they're very complicated, but just whatever you do, try to follow the framework. And even if, like, let's say this question was more complicated for you, just go up here all the way back to when it was a little bit more simple and just kind of try to understand it again and, you know, kind of rewatch, see what I did, and try the framework. And I definitely recommend going to Runestone Academy. And on Runestone Academy, there's a easy, medium, and hard, okay? The link that I'll provide, I'll have a link for the easy. But if you click on the arrow on the bottom right, you can get to medium and get to hard. So if you're having trouble, just start with the easiest, like on the easy section, and just kind of go through them and use this method. And don't worry about your time right now because, you know, obviously you're not being timed right now. You're going to get faster with practice. So just, you know, go slowly, practice, write everything out if you have to. Even if it takes you, 5 to 10 minutes to complete one problem, it's fine because you are doing it and you are learning and you will get faster with a little bit more practice. So if anyone has any questions, especially on recursion, because this is a concept that a lot of people mess up or have a little bit of confusion about, definitely leave those questions in the comment section below. And of course, recursion is for exams that are not 2020 because 2020 was weird with the entire pandemic. So the 2020 exam did not have recursion. In fact, it didn't even have from units 8 through 10. But if you're taking the exam any other year, this will be on the multiple choice section. This shouldn't be on the FRQ unless you change something, but it will be on the multiple choice question. And they'll ask you a question like this, and it will probably say, what is the value returned when you call this type of function. So getting used to this framework is going to be really, really helpful for you on the exam. Alright everyone, if you liked the video, feel free to like and subscribe for more content. As always, thanks for watching.